All right, welcome everyone to week 11 of our nand2tetris study group. Week 11 is probably a lie. Well, it's definitely a lie because we've had to take some extra time to get this project completed, and life got busy and all those things. So this is really just project 11, probably week like 30 at this point. I don't really know, but anyway, I'm Michael Reese, and with me is Dan, aka Richard Stallman Dorman.
Only if Richard Stallman's an abject failure, because only one of us completed the project this time, and it wasn't me.
So yeah, this week is the second part of the compiler for the Jack language, and I guess we'll just dive right in. Do you have any notes or thoughts, Dan, on things that you found particularly challenging or that were surprising to you along the way?
Now, I guess, I don't know if surprising is the right word or not, but I guess some observations are just that what I thought would be relatively straightforward, like I already had basically the AST I needed to process, I just didn't realize how much manual handling of my syntax tree I'd still need to do to make the compiler thing happen. So it ended up being a lot more code, a lot of repetitive code, and I just didn't feel like I had the time to go and look for any abstractions to pull out and make it easier on myself. So it ended up being a lot of boilerplate stuff that wasn't a whole lot of fun, and I think that contributed to my overall apathy towards finishing it. Although I got a little bit of momentum going this weekend finally when I sat down and started working on it again. I was rejuvenated and started making progress, but still I think I underestimated just how much just sheer almost grunt style programming would be necessary to make this happen.
Yeah. So I had somewhat of a similar experience, I think. It definitely, I think we said this last time with the last project, that the tokenizer and the lexical analyzer, the tokenizer went pretty smoothly, the lexical analyzer had a lot more gotchas, there was a lot more, once I had the pattern of how to solve the problem, I was thinking oh, okay, great, now should be easy sailing, but there was still just a whole lot of cases that you had to account for, and it became mostly repetitive coding. And you managed to abstract a lot of that away in your implementation, and mine was a little bit more brute force, perhaps is a good way to phrase that. But then this week, with kind of this resolving your symbols and then starting to actually try to generate the bytecode, I definitely ran into some gotchas. So I made myself some notes, and let's see. The first one I put a note on is they start off this project by saying, okay, you should have the idea of a symbol table, and I really didn't want to end up with two data structures. So I didn't want to end up with a AST over here and a symbol table, which would be a separate data structure, because I knew that that would mean I'd have to pass both of those into my my bytecode generator, whatever piece of code that ended up being, and which would mean I'd have to kind of slowly destructure each of those data structures, but at the same time, which seems like it would be a huge hassle. So so their suggestion for how to get started with a symbol table was really useful. They basically said, every time there's an identifier in your program, try to figure out just instead of it just being a string, oh, I have an identifier called simple. Instead of you just saying it's simple, make it be a map object or a hash object where you know, oh, this is a class name and the name is simple and its type is whatever. And so they started you off with a few things. You should be able to categorize each identifier as either a class, subroutine, whether or not that's a definition of a subroutine or a usage of a subroutine. And then also whether it was, if it wasn't one of those two things, then it would be like a static variable, a field variable, an argument, or a local variable. And so I thought that was really useful. That was a good first approximation. But then if I got all that done and still tried to process my AST, I would still have to do a whole lot of work in my bytecode generator to like discover the context around that part of the AST before I could actually make use of it. And so a couple of notes around that are, once you get like the basic symbol table that they suggest working, I would highly suggest that whatever piece of code that is that's doing the replacement of your identifiers with that extra information, I would also try to, at that point in your program, add, if it's a variable, figure out what its type is, resolve its type, whether it's a built-in type like int and bool, or whether it's a class. Because later on, if you're trying to call a method and you have something in your code that says like do game.run, you need to know what the class of game is so that you know what subroutine you're calling. And so I added some extra steps to, like I kind of got moving on my bytecode generator and kept coming back and adding a few more things to my symbol table piece of the code that was resolving all the identifiers. And then the other thing I found really useful was I started trying to implement control structures like while loops and if-else structures in my bytecode generator, just using the AST as it came out of the lexical analyzer. And it felt really clumsy to me. I had to skip over lots of pieces of the AST to know whether or not there was going to be an else statement to go along with this if. And because of that, my bytecode generator became really complex. So I went back to my symbol table resolver and had it find wherever there was an if structure, it would just replace the whole AST with a map. And the map would contain a key for which instruction should be run if the condition was resolved to true, and which one should be run if it resolved to false. And so like I did a lot of that as a pre-processing step before I actually got to my bytecode generation. And that did keep my bytecode generator a lot simpler because it could just like, it didn't have to walk the AST to discover that stuff. It could just say, oh, I know that my condition is this expression. So I can just compile that expression into bytecode, and then whatever's on the stack right now is true or false. And then based on that value, here's some labels, and here's what should happen if it was true, and here's what should happen if it's false. So it made a lot of those kinds of things a lot easier. So I would recommend start with the basic symbol table that they suggest, but don't just end there. And for sure, the final suggestion, which I'm sure everyone can tell based on the fact that we had like a month-long hiatus between Project 10 and Project 11, is set aside lots of time for this, especially if you are taking it as part of a university course and you have a deadline. Plan on the fact that this is going to be a long project because for me, at least, the number of hours I spent working on it, this was by far the longest project of the whole course. So I don't know, Dan, that matches up with your experience.
Yeah, certainly. It certainly seemed like the most time intensive, and like I said, I still haven't finished it, so yeah.
Well, I will say once I got the first project building and compiling and running, the other three, I think that was about 75% of the time I spent on the project was just trying to get the first one compiling it all. And then once I got it fully working, I think I had the other two ones working, or the other three programs. The next one I think took me another 3 or 4 hours, and then the other two were both like an hour apiece. So, so you were in the final stages, my friend.
All right, great. Yeah, I think I'm going to push through and try and get this done anyway, because I think the other part of my problem, and I would recommend anybody listening that is doing this, try and actually follow the order of the programs they give you at the end, because it builds fairly gradually from what I can tell. And I just sort of started like building my thing and just building the features I wanted to like compile right off the bat, and yeah, and then I felt like I wasn't making any progress because I didn't have the intermediate steps there. So, and then I felt like when I went back and started just working on the 7 project first, it was like, oh, this this is pretty easy. I probably should have just started with this. What I'm hoping, though, is when I get to the parts, and this has already started to bear fruit, when I get to the parts that are using those things I've already built, well then there's a pleasant surprise in that they already kind of work. So that's been nice. But listeners at home, please just follow the plan that they laid out, because as usual, the authors did a really good job of kind of giving you a path you can follow when you're building these things, and I just ignored it at my peril.
That is sound advice. I think it sounds like I maybe suffered through a little bit less of that than you did before I was finally like, I know I don't have to generate the same bytecode that they do, but I'm actually just going to make that be my first unit test, was like use the built-in or the provided compiler and just expect my thing to emit the same bytecode. And I know that I wouldn't have to follow the same conventions that they did. Like, there's other ways to structure an if statement besides the way they chose to do it, but I just followed all their conventions because I was like, well, they got it all working, right? So I'm sure they ran into a lot of the same problems that I'm going to run into anyway. And at some point, I just was so hungry for the fact of, like, I just want to have a program that compiles and runs, and then I can start adding on all the rest of the stuff. And so in some ways, I almost wish they would have started you off with, I wish they would have given us 5 programs and just had the first one be like a literal hello world program that just printed out hello world. And I think that actually would have been really helpful for me to even have one more smaller step, so that I had one example of an end-to-end, like take in the string, emit bytecode, run it in the virtual machine emulator. That would have been really, I think it would have helped me to feel that sense of progress and keep myself moving.
Yeah, I think that's a good idea.
So do you want to start off showing any of your code, anything that you think is interesting or difficult?
Oh, man, no. But let me see. I can kind of, I guess, let me look at like a relatively representative sample, perhaps, of stuff. Maybe. Sure. I guess I can show this portion. Ugh. All right. Yeah, this is some fairly gross. And anybody that knows Clojure, I'm sorry. I'm still learning. So anybody watching that is like, what is this guy doing? Please get in touch and let me know what I'm doing wrong. I'd like to get better at this. Okay. So is that? Can you see that? Should I bump up?
Yeah, I'm seeing it. You want to bump up the font maybe one more? There you go.
And all right, so here's largely the approach I took in a lot of cases, is using Clojure's multi-methods. In this case, this is compiling a term portion of the AST. And then with that, it's sort of like, I guess, a form of polymorphism. So based on the output of this function here, the argument to the multi-method, you can figure out which of your little sub-methods you're actually going to call. So then you can see these following ones, like compile term for var name, here's what to do. Everything basically pushes these vectors into kind of a list. So what I end up with is just kind of a list of strings, essentially, that are doing things. So they're fairly like small units of code. Each of them is fairly self-explanatory unto itself. But there's a lot of these little things in here, and it kind of feels like it's starting to lose track just a bit. You kind of see there's just different things for stuff. And then in most cases, there's a subroutine call. S keeps going. You also have like a default method that gets called if nothing else recognizes it. So that's kind of what I've been using, like figure out, that's what I haven't implemented yet, and then what does my AST look like? You can kind of see, if you look at some of these, like I sort of did what you said you were trying to avoid, where I'm passing the lookup table around to like everything, essentially. But hey, that's all right. And then this first argument, this is the AST, and you can kind of see I'm just using some of Clojure's powerful destructuring stuff. Just go ahead and grab the portions of the argument I'm interested in before I process it. In some cases, I think I went a little bit overboard. Like if you look at this thing, man, what exactly did I have here to start off with that I wind up just caring about the unary op variable and the term variable, and I extract those from the argument. Who knows if that'll be maintainable in the future? I won't need to maintain it, so I guess that's cool. But yeah, the lookup table was pretty cool. I mean, I just obviously did that using like a hash in Clojure. The thing that's nice about that is where they're non-destructive data structures. It's easy to just kind of pass those into individual methods and layer the local variables into it without blowing away the global thing. It just doesn't get destroyed. Yeah, I don't know. That's basically it is a series of these things. I'm either compiling terms or expressions. There's also a large part of things where I'm just extracting variables out of the AST. Yeah, this is kind of what I was alluding to before about it being sort of a pain in the butt to work through my AST in a reasonable way. Yeah, so I don't know. I think there are better ways to do that. I probably could have thought about the data structure of my AST a little more clearly, and I could probably be just handling that in a better fashion. But live and learn. I've still appreciated just having a chance to dig in and munge data with Clojure. It's been a lot of fun. This is kind of an example, I guess you can kind of see where it's building up the symbol table. In this case, the dict or dictionary is the symbol table, and this is just using the Clojure's assoc function to go ahead and append new variables into the symbol table as it goes. Yeah, I don't know that there's a whole lot more to look at. It was probably already pretty boring, but do you have any questions or is there anything I can show you before we look at your solution?
So one question I had, I noticed about halfway through working on this project that that my compiler would not catch basically any type errors ever. So if I have a field in one of my Jack files that was like, oh, field, and the type is some class no one ever wrote, and the name of it is X, currently my compiler wouldn't do any sort of type checking. So there's no sense of I really just that symbol table exists only within the scope of a class, and like you said, it gets passed down to a subroutine, and once I'm done with that subroutine, the data that it appended to my symbol table just kind of falls away when I go to the next subroutine, because same thing. I'm using a functional language that has non-mutable data structures, and so it just kind of naturally falls out in a nice way. But one downside of that I kind of noticed partway through was that it meant I don't really have any type safety. The only type safety is that I would try to call a function, and I guess my virtual machine would explode at that point, theoretically. If my virtual machine was doing something type safe, I actually don't know where that would go wrong. So I'm just curious if you thought about anything along those lines and if you found any solutions for that.
No, the same exact thought crossed my mind that this is a problem, and I'm basically just grabbing this type as kind of a namespace, and if that doesn't actually exist, well, things are going to blow up. But they kind of mention, even in the text, it talks about how the type safety, any kind of idea of types is sort of an illusion with Jack. That even the arrays are just essentially references of things, so it doesn't matter what's actually in them.
Yeah.
So it seemed kind of curious, and I wouldn't be surprised if maybe that stuff is mentioned or dealt with in kind of their addendum chapter. But for now, it was just sort of a thing that I had kind of in the back of my mind. It was well, that's interesting, but I'm not going to do anything about it right now.
Interesting. I was once again too lazy to read the chapter, so I noticed it, but didn't realize that they had addressed it in the text.
Yeah, I skipped most of the implementation stuff, which is probably why I went so far astray. Oh man, yeah, I don't know. I didn't even look at the symbol table stuff that you're talking about, so hopefully I'm approaching it in some sane way that won't kill me when I move on to other stuff.
Cool. Well, let's see. I will actually then, I'll just go ahead and show a little bit. A lot of mine was similar to yours, surprisingly similar given that neither of us, it sounds really followed too closely their suggestions. So So let me just pull up my code here, and we'll just share this terminal. Is that showing up okay?
Yeah, that's good.
So, so let's see. The main thing, kind of the symbol table is probably the first thing that's worth looking at. And what's interesting, one thing that was interesting to me was that when I was building my lexical analyzer, I really specifically wanted to make sure that there was a piece of my code that handled every part, every token that was coming through as I was kind of choosing to start nesting those tokens and figuring out the structure of the program and trying to encode that into the AST. I wanted to like make my program just explode if it saw a token that it wasn't expecting, because I wanted to make sure that I knew that this program was like a valid program, that it was using the syntax in the way I expected it to be used. And so I started off by writing my symbol table to do the same sort of a thing and be very specific about its pattern matching. But pretty quickly I realized that there's actually a lot of stuff in the AST that's not useful for me to like consider on a case-by-case basis. There's a lot of times where it's just like, you know, oh, I'm in the subroutine body now, and okay, like I just saw a curly brace go by, but that doesn't mean anything. Like I'm not going to make any decisions based on that curly brace, so I just ignore it. And so I ended up with a lot of my functions. You'll notice this pattern, and I probably could find a good way to like encode this pattern into a macro or something if I was a proficient Elixir programmer. But for now, this just is kind of all over that. You'll see this thing where it basically says like, hey, if none of my specific cases, like if none of these things happen, then if you basically get to the end of the list, like there's nothing left in the AST, then just return, have some sort of base case. And then if I still haven't matched anything, and then all you should do is just basically throw away this head. I don't need it for anything. Just kind of append it to my outgoing AST that I have tried to encode all my symbol table into the AST at this point. And so I just add this token back into that outgoing AST and move on with life. And so I thought that was interesting that last week, that trade-off, I wanted the opposite result. And this week, because of the type of data I was dealing with, I wanted less safety, and I wanted more just like convenience of, if you don't know what this thing is, I don't want to have to tell you, because most of the time I don't care. So I thought that was an interesting difference between last week and this week. And for the most part, this symbol table, my symbol table implementation has just kind of this entry point where I pass an AST to my resolve function, and it starts off by basically like giving me this blank data structure here to say like, oh, my class, I don't know what my class is yet, but I know I'm going to have a class, and I'm going to have an empty map of fields, an empty map of statics, an empty map of arguments, and an empty map of vars. And so then that just gets passed in everywhere else, right? So all these other functions basically start walking through, and it's like, oh, hey, if the next thing in the AST is the keyword class and an identifier, then I know that that identifier is my class name. So I'll append that information to my symbols data structure and pass that down. And so like within this module, I end up passing the symbol table all over the place. But the neat thing is that when I'm done walking through my whole AST, I only pass back the AST. And now what I've done is every time I have like an if-else structure, I've replaced that with a more specific data structure that only has the information I need, and I've resolved all the symbols to like fully qualified names at that point in the AST, so that later on my bytecode generator just has all the data at hand as soon as it's at that part of the AST. And so I didn't really plan for it to work that way when I started, but it just kind of fell out that way. And most of my tests, let's see, here's a good example of my test. So I kind of started off, like I mentioned, I really wanted just something even more simple than the first program that they gave us. Actually, I think this maybe is that very, very first program that they gave us. It's just this 7-1. which is pretty darn simple. And so I knew that like, hey, this is what their compiler generates in terms of bytecode. So my first test is just like, hey, if I have this Jack code and then I expect to get this thing out, then if I compile my Jack code, I should get that thing. And it's just like a little string comparison, which makes my test really simple to write, but maybe isn't always the most efficient way. And then I have a few places where like trying to deal with or trying to figure out how to write an if-else statement in the middle of another larger program I felt like I was losing context of things a little bit. So I would kind of just like make up a very small example, and then I would use their Jack compiler to generate the bytecode, and then use that as a guide of like, okay, now I know I should be generating something like this. And again, obviously, like my labels wouldn't have to match the same naming convention that they use for their labels, but it ended up not being that hard to use that convention, and it just kind of worked for me. So once again, the somewhat boring but useful pragmatic approach of just saying like, if I have a known good implementation, let's just start by writing a test that assumes I should do the same thing as the existing implementation. And then I just added tests for all the other, and I started off with just the top test, and I've kind of slowly, iteratively added these other integration tests of saying, oh, okay, yeah, take this square main.jack file, and I should compile it, and I should get the same thing as a square main.vm file. And so that just was kind of my pattern that I followed. And once I started trying to follow that pattern, then my development felt like it went a lot smoother. And then the last thing that's probably worth mentioning is, let's see, the actual compiler. Oh, actually, that's not very useful. What I want is Jack, my instruction module. So this is the thing that basically I pass in an AST, and this is really like my enriched AST. That's probably not a good term for it, but it's my AST that I've kind of pre-processed, so all my symbols have been resolved. I know all the types of things. I know that this is the first if expression within this class versus the second or third, so that I can do all my labels right. Like all that stuff is already here. And so the only thing that I found useful here, other than just walking the AST literally piece by piece, was that I pass around this additional value called my path. And this is sort of like, how do I want to explain this? So if I just, let's just say I have like some temporary file here. If my AST looks something like this, like I have some data structure where it's like, oh, I have a class Jack, and then I have a subroutine deck, which is like a nested structure, and then I have some identifier down here. This is not a valid AST, but you're getting the idea.
Yeah.
And so basically what I wanted to do is say like, oh, when I run into an identifier, it depends on whether I'm inside of an expression, or I'm inside of a term, or I'm inside of a subroutine declaration. And so the path ends up just being a list of these values. And so like when I first start parsing a class, I know that the first thing that's going to be on that path is that I'll end up appending a class to it. So whenever I dive down another level into my AST, that gets added to my path. And that just makes it easier for me to pattern match on things. So for instance, here, whenever I'm inside of a term, I can find unary operators really easily by saying, oh, it's a unary operator if I find this, not, this logical not, and then some other term. And like, great, then I can just like parse that next term and deal with it. And there's a few places that I kind of invented another level within my AST for things like figuring out whether this is a minus versus a negation. Whether it's a unary or a binary operator. It was kind of easier if I knew kind of the state of my AST right now, what part of the AST I'm in. So it was at least helpful for me to like say, hey, I'm just going to make a rule that if I'm ever inside of a term, so this is like an example of saying like, I know that my path is the last thing in the path is a term, and then I don't care what else is above that in my path. But if I know that I'm in a term right now, and I'm looking at an integer constant, then all I have to do is emit a bytecode like push constant and whatever that constant was. So, so that became really useful for me, and everything mostly just fell out of this. So my whole, let's get rid of this guy, but this whole like instruction generation piece ends up being, let's see, I actually haven't really measured it. 120, 150 lines. Oh, that's it. So basically 150 lines to do all my bytecode generation. So I felt like, all things considered, that wasn't too bad. And I think doing more work in my symbol table to like try to compress parts of my AST and add other useful information to my AST during that step really saved me a lot of work over here in this step, because it just made it so much easier to kind of say like, oh, if you find a while statement, I just know all I need to do is grab the condition, grab the statements that are part of the inside part of the loop, and this index is like, oh, this is the first while statement, the second while statement, just so that I can make unique labels for my go-to calls. So that was pretty much my whole compiler was mostly just that symbol table and my bytecode generator.
That's awesome. It's very clever. The extra step there of layering on some more, not necessarily straight up, maybe not, I don't know what the term is, pure AST stuff, but shoving in like the if thing. That's a really cool idea.
Yeah, and that I think the only good decision I really made was I was like, I'm too lazy during bytecode generation to figure out my context. So it has to be someone else's job to like make sure that when I'm looking at this piece of the AST, I should only have to look at this one piece to emit all the bytecode I need. And so working on my symbol table, bytecode generator, and try to get the next thing working and realize, oh, I don't know whether this is the first or fifth if statement, so I'm going to have to make sure that that's being tracked inside my symbol table step. So, but I mean, that structure ended up working out really well for me, so I would recommend it. I'm sure there's probably better ways to do this stuff. I don't think either of us are language experts or implementer experts for languages, but I think the design decision of saying that you shouldn't have to look at the rest of the AST ahead of you or behind you to know what bytecode you should generate right now is probably a pretty good decision.
Yeah, I think it's fair. Fair to say.
Well, I don't have any other advice for anyone who's following along or is about to embark on Chapter 11. I think plan on lots of time and try to get something running as early as possible. Probably the best tips that I can give. Any final wisdom from the mouth of he who writes closure?
Nope. Just echo what you said. I think you hit the nail on the head.
All right. Well, in case I don't think anyone really cares about the scheduling of our episodes here, but in case anyone does, we will probably have a little bit of a hiatus once again before deciding if we're going to tackle the last chapter of the operating system. We're both just busy with lots of other things, and for us, this is mostly a hobby and just something for our own learning, and so it's not always the top priority. So I guess if other people have good tips for the operating system chapter and project, feel free to send them our way. Save us some time, and otherwise we'll just get back to people, and we'll eventually post a video about that if we end up actually doing it. So thanks again, everyone, for studying along and for making this such a fun experience, and specifically Dan, once again, as always, I super appreciate the time that you take to do this study group with me. I know life's busy and all that stuff, but I'm really glad I have someone to do it with, and it's a lot more fun for me to be able to compare notes and see what decisions I should have made, so that I know what to do next time.
Likewise, that's definitely been a pleasure. I've learned a ton. I think it's been a lot of fun just having someone else to like kind of sync up with after the fact and just compare notes. I definitely feel like I've learned a bunch from seeing how you do things. Yeah, it's great. I feel like you got tons of good ideas, a lot more rigor around the testing side of things. I definitely got to try and integrate that better, but it's been awesome.
All right, well, with that being said, we'll catch everyone at some point in the indefinite future. And a final note, we probably will be starting another study group after nand2tetris. We're thinking about doing a book club for the book Programming Pearls. Here in our local Ruby meetup group, it's called URUG. It sounds like there will be some other people joining us for that. At least a couple people from the mailing list have hit me up again recently to say, hey, when's that thing actually going to start? Because I already bought the book. So that's a promising sign.
I'm one of those. When are we going to start the study group? I've already bought the book.
So whenever we finish other things, that's when it will start. I don't know. I'm thinking that maybe sometime around Christmas break might be a good time to actually start it, because if we start at a time when people have free time, like they're off of work and stuff, then hopefully it gives us a stronger start. Because I think we lost, we started off this battle of nand2tetris with many more comrades than just you and me, Dan.
Yep.
And so I think having a strong start to it and getting people to the first kind of one of the keys to success for this. So I think maybe sometime around King or Christmas will be a good time to start that, and hopefully it involves a few more people. So if anyone watching this wants to jump in on that, where there's definitely still spots available, we could do with a few more voices besides just me and Dan. So contact us, reach out on YouTube or Google Plus or whatever, and or Twitter, and let us know so we can get you involved. Thanks everyone, and we'll see you later.
All right, bye everybody.